So these are two valves, and they're part of any aerospace or semiconductor equipment, and they're used to regulate the flow of gas. This is a manual valve. This is a pneumatically actuated valve, and this tubing here has got processed gas in it, and so what we typically want to do is make sure that no contaminants get into the system, and we want to make sure no processed gas gets out of the system. In a lot of cases, these processed gases are pyrophoric, which means they'll explode if they touch air or water, or they're toxic, which obviously means they'll kill people, or corrosive, which means they'll, if exposed to moisture or oxygen, will corrode and actually eat the system from the inside out. So this is a fitting that's out there in the industry now. It's my competitor's fitting. And if you put a gasket in there and you tighten it down to finger tight, like this, the two toroidal systems engage into the gasket. Now we tighten this fitting about a sixth of a turn, an eighth or a sixth of a turn past finger tight, and in order to create a high pressure or high vacuum seal. And as I tighten this fitting, you'll notice something happens. So as I tightened it, you'll notice the two components were twisting out of alignment. So no longer is my system nice and square. It's all tweaked out of alignment. And if you say, well, we could always bolt these systems down. We got these screws here. We could just screw it to a plate. Well, if you do that, actually what's called system windup occurs. The two tubes actually have a windup in them, and under shock and vibration, they will loosen. So now how do we prevent this problem from happening? Well, we've got something new out there, and it's called the Omnisafe torque elimination system. It just gets rid of that torque as we're tightening the fitting down. These two torque eliminators are identical. There's one on each side, the male and the female side of the fitting. And they're right here. One's inside the female nut here. This is the one on the male side right here. So these two torque eliminators engage each other into what I call the torque elimination embrace. And as the fitting is tightened, we'll see what happens. So we drop the gasket in like we always do. We push the two fittings together and just start threading them together, rotating them. And right now the two torque eliminators have engaged each other. And I can now tighten the female nut, sixth a turn or up to a quarter turn past finger tight. We can tighten this one harder, it doesn't really matter, because we're not going to have that same problem of rotational torque anymore. So I go ahead and tighten it down a sixth of a turn, go ahead and give it another crank. Tighten it as hard as I want, and totally square, no twist at all installed in the system. So this thing, not only is it free from vibrational loosening under shock and vibration, thermal cycling, vacuum and pressure cycling, but it's also cleaner. It doesn't have this galling which sheds particles in the process stream, and it's also just much easier to assemble. It decreases the system installation time dramatically. And this system will pass leak check immediately instead of having to worry about it. With the other fitting, typically they start the fittings out of alignment and try to tighten them into alignment, so they end up being square when they've tightened them. But it's a real time-consuming technique to go through when you can just tighten it down this way and get it done quickly.